Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I am dealing with spectroscopy for chemistry and particularly ultraviolet visible spectra. This is lecture number 16 in which I will explain you what is hyperchromic shift and if time permits hypochromic shift also. Okay, so hyperchromic shift means high intensity shift. In this case particularly the value of epsilon maxima increased. That means intensity of color increases. Okay, see this, that certain functional groups provide absorption of visible region light, and these groups are known as chromophores. Even chromophores can absorb ultraviolet also. In some groups, in organic compounds, and hence the intensity of color known as oxochromes. Oxochromes alone cannot produce color in a given compound. This may be due to chromophore, but oxochrome may change the intensity of that color. So in presence of such groups, if intensity of absorption of light, that is given in terms of absorbance or epsilon, then the height of peak rise this is known as hyperchromic shift, and it will definitely increase the intensity of color. Okay, now this can be because of the presence of oxochrome. So presence of oxochrome along with chromophore can do this kind of change. How? Let us see this one. We have already taken this example of benzene with absorption is about 254 nanometer and epsilon maxima is about 200, and that is why this compound is colorless. You see, if absorption is less, then it is colorless. Now we will take aniline. Because of presence of NH2 group and lone pair on NH2 group, nitrogen, the resonance increased which will stabilize molecule. NH2 itself cannot give color to the compound, but chromophore getting more and more conjugation. That is why the intense lambda maxima increases from 254 or 255 to 280 nanometer, and along with that you will find increase in epsilon maxima. It is about 1430. Okay, even if it is colorless, it can show color in presence of air because of oxidation. But here you will, if you compare the graph of these two, you will see that absorbance versus wavelength, then the graph for benzene may be like this. This is lambda maxima and the value is 255 nanometer for benzene, and the graph for aniline could be like this, and this will change to 280 nanometer. So here, sorry, along with this, I'll show you this one. And here for benzene, this epsilon maxima is say 200. Then for aniline it will be very high. So it will go like this and comes here. So this is lambda maxima 280, but epsilon value will be increasing to 1430. Okay, so this way the intensity of the graph increases, the height of the graph also increases. That is due to the presence of oxochrome. Second thing, some oxochromes like methyl group can change conjugation also. For example, in pyridine, you will find resonance structures like this. And remember, in this case, lone pair of nitrogen is not involved at all. So these are two resonance structures in pyridine. Lambda maxima is 257 nanometer and epsilon maxima is about 2750. Okay, now when methyl group is introduced to pyridine on second position, along with this resonance in 3 alternate pi bonds, even oxochrome like methyl group in acidic or in basic medium can show extra conjugation like this, and that is why lambda maxima, which will increase because of stability, as well as intensity of graph also increased from 275 to 3560. So this way you will find change in absorption as well as height of the absorption. So these two examples shows that hyperchromic shift. Okay, that's it in this lecture. Thank you so much.